All right. Hey, chemistry students, it's Mr. Caldwell. Wanted to run through the answer to the colligative problem work that was assigned back on Friday. Gosh, that would have been probably May 22nd. So the only problem that you really had to do was problem number three, and it's a complicated one. So I wanted to walk through it with you. You've got this table of data up here and then a lot of information. So we're going to sift through this together and see if this makes sense. So the first thing is this is actually a pretty realistic situation for what a chemist in a forensic lab might do. And so you're trying to determine an unknown chemical. And so we can use this colligative property, the fact that when you dissolve something into a solvent, it changes the boiling point by raising it by a certain amount and or lowers the freezing point. Based on this formula, the delta T equals IMK. So what I did was I pulled out the information for each of the three chemicals that were possibilities. And I said that if I have 10 grams of each of them, because they have different molar masses, we would have different numbers of moles of the substance. All right. And all I'm doing is just trying to get my mind wrapped around some of the information that we have. Then, as we look at it, it says that we took and we dissolved in the 10 grams of our unknown substance, and we dissolved into 250 milliliters of ethanol. Those 250 milliliters of ethanol normally have a boiling point of 78.5, but it went up to 78.8. So we actually know delta T. We know that the change in the boiling point was zero point 0.3 degrees. And since delta T equals IMK, we can start putting these pieces together. So delta T would be zero point 0.3 here. We know that each of these substances are, all of them are nonmetals bonded to other nonmetals. So they're all molecular compounds. And so the I, the Van Hoff factor, is going to be 1 for all substances that are molecular in nature. And then we use the Kb value because we're talking about the boiling point elevated, and Kb from the table above was 1.22. So at this point, I've got enough information to take and plug into my delta T equals IMK. I know delta T, I know I, and I know K. So all I did was I rearranged for M and just basically divided over the I and the K. And so I ended up with a molality of 0.2459. Now, this is where you have to get a little bit sneaky and realize that the density is there for a reason. I told you that the density of the solution was zero point 0.8 grams per milliliter, and I told you there was 250 milliliters of solution. So I can rearrange the formula for density to figure out the mass of my ethanol. And the reason that mass of the ethanol is so important, and mass in kilograms especially, is because the formula for molality is moles of solute divided by kilograms of solvent. So at this point, I now have a way to figure out how many moles of solute I should have had in the work in the problem here. So I take my molality, which I solve for up here, 0.2459. I multiply by the zero point 0.2 kilograms of solvent. That's how much ethanol I had because I didn't know from the original problem how many kilograms of ethanol I had. The only thing that I knew was the volume of ethanol and the density of ethanol. So I had to do some calculations to get the mass of ethanol. So at this point, I go ahead and figure out that I've got 0.04918 moles of solute. And I go back up here and I look and I compare which of these numbers is closest to 0.04918. And it looks like right here, the ibuprofen is the winner winner chicken dinner because 0.048 and 0.049 are really close to each other. And so as a forensic scientist, my findings would be that it appears that ibuprofen was the unknown substance in the victim. So that's kind of a cool little problem. And hopefully all of you are well and that this little video helped you guys figure out some of this stuff. Everybody take care, and I'll see you online soon. All right, bye-bye.